Alright, next up we have some more radicals. The best thing I can tell you is that adding and subtracting, it's always the same rule. It has been in the entire book. You can never add and subtract unless you have like terms. You must have like terms. Same thing here. You can only add and subtract if you have like radicals. And these are not the same. They have to have the same number inside. So therefore, we cannot subtract these. Don't do 75 minus 27. If they're not like terms, then we move on and just check and see if we can simplify. In math, if you can simplify, you always have to. And simplifying is when you take the number inside the radical, it's called the radicand, and do the prime factorization. You can use any numbers you want. The first thing I thought of is 3 times 25 is 75. 3 is prime, so that's done. 25 is 5 times 5. So you just use your prime numbers, 3, 5, 5. And if you can circle a group of 2, a pair of something, you can take that number out. I think a circle looks like an O. So whatever you circle, you can take one of that number out, and the remainder stays inside. Now this had a 2 in front. Make sure you bring that down. So we're going to multiply by 2 here. We can multiply the outside numbers together, and I have 10 radical 3. Now let's do the same thing with 27. 27 also can be simplified because it's 3 times 9, 3 times 3. So you've got 3 3s. With square roots, if you can circle a group of 2, that's what you can take out. Oh, I meant to write that up here. That's okay. And a 3's left inside. Now again, this one already had a 4 in front. So we're going to have to multiply by 4. So we end up with 10 radical 3 minus 12 radical 3. And now the magic happened. Now we have like terms. Now they are like radicals. So after we simplified, now that they're both radical 3 and radical 3, we can go ahead and subtract. 10 minus 12 is negative 2, and you leave the radical the same. So the answer you would choose is negative 2 radical 3. It's just like if I asked you to do 10x minus 12x. When you combine like terms, you combine the numbers in front, and you leave the variable the same. I did that here. I subtracted the numbers in front and left the radical the same. So simplify if you can, combine like terms. Now multiplying is always totally different. This is a FOIL problem. And when you multiply, you do not have to have like terms. Instead, the way I like to think of it is you can multiply the coefficients together. You can multiply the outsides together, the coefficients, and you're also allowed to multiply the insides together. You're allowed to multiply radicals with other radicals, but you could never mix and match. So a real quick example would be something like 2 radical 3 times 5 radical 2. You could multiply the outsides together, and that stays outside. You can multiply the inside numbers together, and that's it. If you could simplify, you would. But never multiply an outside with an inside. This is like a really cool club, and if you're not in the club, you can't get in. So here we go. When I FOIL, I get 4, and 5 times 5 is 25. Next up on the outside, positive times a negative is negative. 5 times 3 is 15. Next up, we end up with a positive 8, radical 15, and then a minus 2, radical 9. Now, if you look at the problem, we're done multiplying. Now we're back to adding and subtracting. Now it's back to what we just did before. Here we have some like terms. We are allowed to combine the radical 15 since they are like radicals. The most common mistake I see here is just like if you have an x and there's no number in front, it's really a 1x. This is really a minus 1 radical 15. So when you do negative 1 plus 8, you're going to get a 7 radical 15. So we can combine these like terms. On the outside parts here, I've got 4 times the square root of 25, which is 5. So this ends up being a 20. Here I end up with negative 2 times the square root of 9, which is 3. So we can combine the two middle terms. I can also combine 20 minus 6, which is 14. So the answer is 14 plus radical 15. If you had it the other way around, that would also be correct. The most important thing next is to stop. Don't add the 14 and 7. They are not like terms. Don't do it. Radicals are a lot like having an x. If your answer was 14 plus 7x, you're done. This has an x, that doesn't. Same thing here. You cannot add a radical with something that is not a radical. So here we are completely finished. Divide and rationalize. You are not allowed to have a radical, no radicals, in a denominator. It's against the law. You cannot leave this radical here. To get rid of this, since this denominator has 2 terms, we're going to have to multiply by the conjugate. That means you leave the numbers the same, you just change the sign. A conjugate is same numbers, different sign. Or I'll write change sign, same numbers. And whatever you do to the bottom, you must also multiply the top by. So we're going to multiply by the conjugate, and we'll get the answer. The numerator, when you distribute 1, this will stay 5 plus radical 3. The denominator, we will FOIL. 5 times 5 is 25. Now, if you remember what happens when you multiply conjugates, you could skip the next 2 steps here. But on the outside, we get positive 5 radical 3. And on the inside, it's negative 5 radical 3. And lastly, a negative times a positive is negative, and we get a 9 inside. These cancel out. 5 minus 5 is 0, and that always happens when you multiply conjugates. So we end up with 25 minus the square root of 9 is 3. Our denominator is 22. And the whole reason we did that is because it works. You can't have a radical in the denominator, and when I multiplied by the conjugate, the radicals canceled out. This one simplified, and that always happens, so we have a beautiful answer. To solve a radical equation, the first step is to isolate the radical. That means you want to have a radical all alone. You want the radical to be alone on each side. These radicals are together. To isolate them, I'm going to add this to both sides. I'm going to add this whole radical to both sides of the equation. Because then I'll have this radical isolated on the left. It's the only thing on the left. And now this radical is the only thing on the right. Now they're alone. Yay. After you isolate, we need to get rid of the square roots. And the opposite of a square root is a square. Whatever you do to one side, you do to the other. Squares and square roots cancel, leaving what's inside. So on this one, when you square, you end up getting rid of both at the same time. And now we just have a regular equation. To solve for x, we need to get all the x's on one side together. So I'm going to go ahead and subtract the 3x. There's other ways you could solve this, but we'll all get the same answer. I'm going to subtract the 3x. Now I'm going to subtract the 1. And I get 4x equals 16. So the last step is to divide. And we've got our answer. It said solve for x, and x equals 4. With equations, those are the best on a test because you can check your answer. You never have to guess in math. I think that's why I like it so much. But for example, if I go back to the original and you plug in a 4, this should equal 0. If you don't get 0, you know you're wrong. But here we would get 28 plus 1, which is 29. I know I'm making a mess here, but you get the square root of 29, minus 12 plus 17 is another square root of 29. So radical 29 minus radical 29 is 0. Anything minus itself is 0. So if you plug in 4, it does work, and that's a great way to check and feel good that you have the right answer. All right. Last thing in Chapter 5 is imaginary numbers. Complex numbers, that's when we're using the imaginary I. Star this one. This is a FOIL question. This might be the most missed question I see. The answer is not 64 plus I squared. Don't do it. You do not just square both of these. Whenever you are asked to square something, it means to multiply it times itself. 3 squared means 3 times 3. 5 squared means 5 times 5. So 8 minus I squared is asking you what is 8 minus I times itself. So this is a FOIL question, so be on the lookout for that. It's sneaky. So when we go ahead and multiply, a negative times a negative at the end is positive, and I times I is I squared. So we have 64. You can combine these like terms. Negative 8 minus 8 is negative 16. And here's where we have to use our law of imaginary math. Another really good flashcard. Whenever you get an I squared, our definition is that it equals negative 1. So since I got an I squared here, that becomes a negative 1. The last step is to combine the like terms. And we have 63 minus 16I. That is it. That's our complex number answer. So whenever you get an I squared, don't forget to turn it into a negative 1. One more. Let's continue using the law. The only one I have memorized is I know that I squared equals negative 1. So I'm not sure what I to the 37th is. But if I can rewrite that using an I squared, I'm going to be able to figure this out. So I'm going to use the exponent rule. I'm going to see how many times 2 goes in to 37. You could use a calculator there. And that would be 18. Our exponent rule was that 2 exponents next to each other. The power rule, you multiply the exponents. So right here I've got 36 i's so far. But I need it to be equal to 37. So I'm going to need to write one more I here. So again, the reason I did this is because I know what I squared is. So I'm rewriting this using the law that I know. Now I've got 37 i's on the left. And here I figured out a way to create 37 on the right. Now I can go ahead and use the law that I squared equals negative 1. And I can do this by hand now. Or you can double check in a calculator. Negative 1 to the 18th is positive 1. Since this is an even number and every two negatives become a positive, it's going to become positive 1. But again, you could do that in the calculator to verify. And 1 times I is I. So on this one, the answer is I. Check out that section again because there was a pattern that 1i equals I squared is negative 1, I to the third is negative I, and I to the fourth was positive 1. And then the pattern repeats 5, 6, 7, 8, and so on and so forth. But instead of memorizing that whole chart, it's easier to just memorize the one law and use that to rewrite all of them.